Hi, everyone. I wanted to create a quick video on security scanning in GitLab and how it works. I've had a couple of conversations recently with people about customers not seeing what they expect to see or not being clear on which vulnerabilities are being reported or why. So I wanted to cover some of those details here. So I'm calling this my golden rules of GitLab security scans. And the first one is that every security scan runs as part of a pipeline. Now, GitLab CI is the core of GitLab functionality. So all of the security features that we have, for the most part, there's a couple of exceptions now, but for the most part, if you are enabling security scans, you are going to see a pipeline run. I think there may be one exception to that today, but I will have to get back to you on that. This is important because the first thing that you want to check if you are not getting results that you expect is, did a pipeline run? When did the pipeline run? What jobs were included as part of that pipeline? And that's true whether you're configuring the scan through the UI, you're configuring the scan through scan execution policies, or if you have compliance frameworks with corresponding compliance pipelines set up for projects, you're going to see the scans run as jobs that are part of some pipeline. They'll be added either to the existing pipeline definition as those pipelines run. For example, when you're committing and pushing changes to a feature branch and you have a scan execution policy to run for unfeature branches, you will see the appropriate scans added to those jobs. Or if you have a compliance pipeline associated with the compliance framework for a project, that compliance pipeline will define which scans will run in which stages. If you have scheduled scans, you can set directly through the UI scheduled scans on one or more branches as scan execution policies. They run as pipelines. So at the time of the schedule, you will see a scheduled pipeline kick off. You will see one pipeline for each branch that you specified should be scanned. It's important here to check the pipeline because the pipeline has to run successfully in order for the vulnerability findings to be reported. Now, with the scheduled scan, something I ran into recently, and I just want to point out, because scheduled scans are, as policies, are newer functionality, new-ish. You have the opportunity to run a scheduled scan on all branches if you choose to do so. That's one of the options in the UI. You want to be careful and advise customers to be careful about doing this, because when I tested this recently, I scheduled a SAS scan to run. The SAS scan, because of my repository, is actually 5 different analyzers running, 4 different analyzers running in this case. And I had 30 branches. Many of them were very old, stale branches, but I had 30 branches in my repository. So I kicked off 30 pipelines, each with 4 scans that ran daily from the time I enabled that policy. For people using GitLab shared runners on gitlab.com, you're going to burn through a lot of runner minutes just by doing these scans on all branches. For people using self-managed runners, they're still using compute time and paying for that. However, they have their runner set up that they're managing themselves. So it's important to be mindful. What branches do you really want to scan? What's the purpose of scanning those branches? And probably don't ever, with maybe 1 or 2 exceptions I could think of, but in most cases, you don't want to scan every branch in your repository. Rule number 2. Each pipeline scan job produces a JSON report that shows the vulnerabilities found during that scan. So as you go look at the pipelines, you want to look at each job that ran. And on the security tab, you will see an option to download each of the vulnerability reports in JSON format. You will see, as part of the job log, that the appropriate JSON report is uploaded as an artifact for that job as part of that pipeline. Each type of scan has its own naming convention. So for a SAST scan, we will see a GitLab gl-sast report.json. And this is great. Now, you want to be a little bit careful here because some things can go wrong. Either for some reason a report can't be uploaded if the scan didn't execute successfully. You won't see reports, you won't see the vulnerabilities from that scan. Even if the scan ran and then somehow the artifact report upload got messed up, you won't see the results of the scan. So keep that in mind. With certain scanners, so SAST is a special case, so you will see different SAST analyzers run for different types of code, and all of those results will get aggregated. But for things like a dependency scan, let me scratch that. Container scan is the case I have in mind, where we look for a Docker file and we scan based on the first Docker file we find in a repository. A lot of customers have tried to have multiple container scans running in the same pipeline, each referring to a different Docker file. So container scan 1 scans based on Docker file 1, container scan 2 scans based on Docker file 2. When you have a large mono repo, you will often have cases where different modules have their own Docker files, so you want to scan each of them. If you just do it like brute force, container scan 1, container scan 2, each pointing to a different Docker file, extending the standard container scan, the first JSON report for container scanning gets created and uploaded as an artifact. Then the second job runs for container scan 2, uploads a JSON report with the same default name if you don't specify a different name. And the result is that the second JSON report has the same name as the first and basically is overwriting the results of the first scan. So you want to be careful whenever you're running the same exact scan analyzer as jobs at separate points in your pipeline. This can cause results that are unexpected. Okay, golden rule number 3. The vulnerability report, security dashboard, and dependency list that are all found on the secure menu are data from the most recent successfully completed pipeline on the default branch. So 2 key aspects here: default branch and successfully completed pipeline. And those things will trip up customers as they're starting to see, or as they're starting to look at the results in the vulnerability report and security dashboard and their dependency list. So if for some reason we're not seeing what we expect in those reports, we want to look at how is the default branch defined for that project? Did the most recent pipeline on the default branch complete successfully? If it failed, even if those security scans ran successfully, but something else in the pipeline caused that pipeline to fail, the security results are not going to be uploaded to the vulnerability report in those dependency list and security dashboard. And then when you look at the most recent successful pipeline on the default branch, did it contain the scans that we expected to see? Sometimes we have rules in place that different jobs run on the default branch versus jobs that run in feature branches. So we want to be careful about that. The good news is that the vulnerability report will tell you which pipelines it's pulling the data from. So you can go and see the security report pipeline to see which scans ran, validate that JSON files were uploaded successfully. And then for the dependencies for the SBOM, you will get the most recent pipeline for that as well. In my case, I removed the dependency scan after I had run some pipelines. So my most recent vulnerability reports are using a different pipeline than the SBOM because the last dependency scan job was run a month ago before that job was removed from my default pipeline. So you'll get these discrepancies sometimes. So it's important to look at the details of what each pipeline is that's producing the report data that you're seeing in those reports. Now, I cannot emphasize enough, branching strategies matter when it comes to pipelines and when it comes to the security results we're reporting in those pipelines. I've seen customers do a lot of crazy stuff here. So sometimes the customer changes the default branch after a bunch of feature branches are created. So the branch that's being merged to from the feature branches is not actually the default branch anymore. And so when they merge those feature branches in and they expect to see the vulnerabilities in the vulnerability report, they're not seeing it because, as it turns out, their feature branches are merging into a dev branch, let's say, and they've created a separate prod branch that they've now called the default branch going forward. We need to check that they're merging their feature branches to the default branch and the pipeline's running on that default branch. That's a project setting. So you can go into your project settings and check what do they have set as the default branch today. The vulnerability report is only ever going to report data on the default branch. Okay, and then one customer had this great branching strategy that they devised, whereas they were getting ready for new release candidates, they were creating release branches, but then they were changing that to be the default branch. And every week their default branch would change. And as a result, the reporting of the vulnerability report and the dependency list and the trend of vulnerabilities over time, there was no consistency at all. It really made no sense. They weren't reporting on a consistent thing over time. So make sure that you understand the customer's branching strategy and whether or not they are doing something interesting that might impact what they're seeing in the vulnerability report. And then the third case I had, it was particular to DAST scanning because DAST doesn't depend on really anything that's in a particular branch. DAST is related to an environment that's being scanned. You provide the environment URL. What you should really do is have different branches that are defined for different environments. In my case, what we were seeing is that the customer was running as part of a scheduled pipeline, a scheduled DAST scan. They were running a DAST scan against a dev environment and having that reported, but it was being run as if it were against the default branch, right? So the pipeline was associated to the default branch, but it was using a specific environment that they specified for the scan. And then they were doing a separate DAST scan on a completely different environment, but also associated to the default branch. And they were running that directly after the first DAST scan. So they would see the results of the first DAST scan, they would see the vulnerabilities on the vulnerability report. Then the second DAST scan would complete and it would wipe out any vulnerabilities from that first scan and now report the DAST scan results from that other environment because they were all being run against the default branch. What we advised them to do was to create two separate DAST scans, run them as scheduled pipelines, one against a stage environment, one against a dev environment, or whatever those two environments were. And then look at the pipeline security tab to see the results of each. Unfortunately, and I know we have some enhancements logged in GitLab, and it's something we're considering, if not already planning on doing. But unfortunately, right now, the vulnerability report can't tell us, it's not, we can't switch which branch we're looking at. It's only telling us the default branch vulnerabilities. So if I want to have a nice UI view of all of the stage branch DAST vulnerabilities, I have to go find that pipeline that most recently ran and go to the security tab and look at the results there. And that brings me to golden rule number 4, which is that the security tab of a pipeline shows all the vulnerabilities found in the code being scanned as part of that pipeline. Or with the case of a DAST scan, it shows whatever environment was specified as part of that DAST scan. So I use the term code being scanned loosely here. We know sometimes it's source code, sometimes it's container images, sometimes it's packages based on dependency, package files, etc. Now, what gets confusing about the pipeline view is that if you are, let's say you have run scans against your default branch, you have a set of vulnerabilities listed, you've gone in and you've marked them as false positives, you've resolved some, you've dismissed some. Now you create a feature branch and you run a new pipeline that scans the feature branch. If you look at the results of the scans from the pipeline itself on the security tab, you are still going to see all of the vulnerabilities that you already knew about in your default branch. So even if you dismiss them, although there is a toggle now that it's been there for a while, I think, but I just noticed it recently. By default, there's a toggle that will that's turned on that will remove the list of dismissed vulnerabilities from the list that you see in the security tab. But you can toggle that on or off. So dismissed vulnerabilities, you may or may not see whether, depending on whether that toggle is on or off. Resolved vulnerabilities, if it's still a vulnerability in your code base or in your dependency list, if the dependency still has a known vulnerability, even if you've marked that as resolved, as not something of not a concern, a false positive, if you're resolving instead of dismissing resolving instead of dismissing the vulnerabilities, it's still a vulnerability that we're finding in the scans. So the security tab is still going to report that vulnerability. It's still a known vulnerability that exists in your repository in that branch that's being scanned. So here's an example. Screenshots are a little small, but the vulnerability report in this case shows a dependency that was resolved. It was a high severity vulnerability, but when we analyzed it as a security team, we decided it was not something that was of concern. It was something we are willing to accept, and we marked it as resolved. You could argue whether you should mark it as dismissed or resolved, or maybe we introduce the mitigating factors to no longer need to worry about this vulnerability. We marked it as resolved. When we ran the next feature branch pipeline, as we were developing a new feature for the same code base, we still see that vulnerability as a high severity vulnerability. If we click on the vulnerability to look at the details, we will see that the vulnerability has been resolved. And if you have the dismiss toggle off, you would also see all the dismissed vulnerabilities. But as you look through each one and look at their statuses, they will be reported as dismissed, right? We're reporting them here because as we run the scans, we know that these are vulnerabilities. The JSON report is going to show them as vulnerabilities. Now there's 2 exceptions here, and I forgot to call out the second one. The first one is secret detection. Secret detection works differently than SAST, container scanning, dependency scanning, DAST scanning. Secrets detection scans a set of commits using the initial commit known based on when you created the feature branch to the present. There's some weirdness there that I still don't quite understand about how sometimes it finds the correct set of commits or not. But generally, by default, it tries to find what are the commits that need to be scanned to find secrets in any of those commits. There is an option to enable historic scans with a variable secret detection historic scan. And if that's set to true, it scans the entire repository. It doesn't care about which branch you're on. It scans the entire history of the entire repository. So you're going to get different results for your secrets depending on what it's scanning. So you may or may not see previously found vulnerabilities depending on how you have your secret detection scan set up. Okay, so that's an exception to what I just explained about the vulnerability report. The other exception here is that if you turn your scans on, get your initial set of results, and then start tuning your scanner rules for SAST, the scan for any disabled rules, those scan results will show, will no longer show those vulnerabilities. So there could have been a set of SAST vulnerabilities that were found and reported in the vulnerability report, and then some rules were added to disable some of the scan rules. Sorry, rules were added. Rules were disabled, so a file was added, a TOML file with a set of custom configurations to disable some of the SAST rules. The next time that scan runs in a feature branch that has that custom rule set configuration, it's going to say, okay, I know I don't need to worry about vulnerabilities with this rule, or this rule. If you're doing a SEMGREP SAST scan, it'll actually look at the rules and no longer even search for vulnerabilities with those rules. So you'll no longer see them in your JSON results or in your vulnerability security tab. If you're doing other SAST scans besides SEMGREP, basically what happens is it still runs the full scan with the default rules that it uses. And then it looks to see which ones you've disabled based on your TOML file, and it will remove those vulnerabilities from the report. So either way, the net is that you're not going to see those vulnerabilities anymore in your pipeline results because you have disabled the rules for those specific vulnerabilities. That was a lot. Sorry. Hopefully that made sense. Golden rule number 5, and here's the good news. So customers sometimes get confused because they look at a pipeline against a feature branch and they look at the security tab and they see a full list of vulnerabilities, even those that they already knew about in the default branch. But what they should be looking at is the merge request widget, and that's going to show only the deltas is how I like to describe it. It's going to show the vulnerabilities that are found in the most recent successful scan of that feature branch associated to that merge request, minus the ones that I already knew about in the default branch, right? So it's really comparing, here's the JSON results in the feature branch associated to this merge request. Here's the JSON results of the default branch with the list of known vulnerabilities based on the most recent successful scan in that branch. What are the differences? The difference is these are the new vulnerabilities found. And the merge request widget is going to be how you want to understand what potential new vulnerabilities are being introduced based on the code changes that are being made in that feature branch. Right? So this is what customers really want to be using when they're trying to understand what impacts are the development teams having as they are continuing to make code changes. And this set of vulnerabilities typically is going to be much smaller than the vulnerability list on the pipeline security tab because it's only showing new stuff that was introduced and not everything. This is also the set of vulnerabilities that we use for those merge request approval rules that you add as part of your policies. So we're not looking at everything when we have policies. We're only looking at what's showing up here in the merge request widget that we need to be concerned about that are impacts of our code changes that we didn't already know about in the default branch. All right, so if you keep all of these things in mind, I wanted to circle back on the scheduled scans one more time based on all of this information. So the scheduled scans will have a set of scans running on one or more branches that you specify. Each of those branches will have its own separate pipeline associated to it. And let me just go back to that page where I showed the set of scans. So we can see when I had my scan all branches rule set up, I had 30 different pipelines run. You can see each of those has a branch associated to it. They each have a different branch name, right? Because it's basically running one pipeline with the appropriate scan or scans. on each of the branches that exist in my repository. So if we have all of these branches, but we don't have merge requests associated to them, we're going to have to go and look at each branch, like I talked about with the DAS scan. Look at each branch, look at the pipeline, the most recent marked as latest pipeline that ran for each of those branches, and then look at the security tab to see the vulnerabilities found, right? So bring it all together, as I mentioned before, the vulnerability report is only showing the default branch. Even if we have scan policies that say scan every branch, we're only seeing the default branch vulnerabilities in the vulnerability report. So the only way today that we can really see results of other branches we want to scan is to go to the pipeline security tab or create a merge request associated to that branch. And then you will see in the merge request widget the new vulnerabilities introduced that aren't in the default branch, but now exist in the other branch that we have scanned. Okay, hopefully that ties everything together. I hope this video helps. Thanks everyone for your time.